Top Med Talk.
Hello, welcome back to Top Med Talk. I'm Andy Cumpstey. I'm here at the American Society of Anesthesiologists annual meeting, Anesthesiology 2025, which this year is in the fantastic San Antonio in Texas. It's a real delight to be here, isn't it, Kate Leslie?
It's fantastic. It's really warm outside, and there's zillions of anesthesiologists here from all around the world, and we've had some great sessions. And I think my favourite session of all is the initial results section, and we're lucky enough on Top Med Talk to interview all of the speakers. So we've talked to Philip Payton about his rocket trial, and we're going to talk to Paul Miles about his ITAX trial. And then we've got another surprise guest that you'll introduce in just a minute to talk about more fabulous breaking trial results.
Thank you very much, Peter Nagele, for joining us here on Top Med Talk.
Thank you for inviting me.
So Peter, could you tell us a little bit about yourself, where you work, what your background is?
Sure. I work in the U.S., so I'm a professor at the University of Chicago, work in the general ORs, and have a busy research program. So the trial was trying to develop or test nitrous oxide, so laughing gas, as a treatment for depression. There has been some interesting and promising early evidence on the use of nitrous, 1 hour inhalation, and then you follow up patients for a while and see how they improve or not. But it was time to really go bigger and ask if a series of treatments would help patients with a prolonged effect. We designed this as a 2-center trial, a phase 2B, so not super early, but also not the definitive trial. And so Monash University in Australia was one site and University of Chicago the other.
And your trial had an interesting design, didn't it?
Well, yes, there was one angle that we tried to ask another question in the trial because the dose finding has really not been completely done. And so we asked, would a lower dose of nitrous oxide, so 25%, have similar efficacy as 50%? And so that was built into the nitrous group, which we split in two, basically.
So just to make it really clear to listeners at home, this trial was sort of asking two questions then at the same time, originally was the aim.
One main question, right? The primary outcome was comparing nitrous to placebo, control, but then it had a sub-aim to understand if there's a difference between 25 and 50%.
And we'll come to the results in a second, but who were you recruiting into the study?
So it followed, I would say, more standard depression research study. So patients with what's called unipolar depression, so who were not bipolar, who had no psychosis or severe substance abuse. So fairly clean patients with severe depression.
And depression measured how?
So most depression trials use a commonly used scale in depression research or in clinical psychiatry called either Hamilton Depression Rating Scale or Montgomery-Åsberg. This requires an interview by a trained interviewer. So in our trial, we used the Hamilton Depression Rating Scale. You had to meet a certain severity, so cutoff was 17 points, that allowed you to enter the trial.
And I've got to confess, that's not a scale that I'm familiar with or had heard of before you presented it today. So saying a severity of a cutoff of 17, what does that mean in practice?
Well, to go back to the question, what is the scale? So the scale is basically a series of either 17 or 21 questions that cover different domains in depression. So one would be, have you felt depressed? Have you felt suicidal? How's your sleep? And each of these questions, your answer, if the patient has no symptoms, right, it's 0 points. And if, for instance, feels very depressed, it would be 4. So you then sum up all the points. And if you're above 17, then you would this is the cutoff for severe depression. So it's really kind of like testing all the domains of depression, of your symptoms.
But these are patients who have got a severe form of it.
Correct.
It's been medicated with other treatments so before going into the trial, and this is not their first.
These are patients who are often referred to departments of psychiatry, right? Severe depression. It's not. So some of my friends in psychiatry call it garden variety depression, right? So a patient has, and that are often good to treat with oral antidepressants. So these are severe depressed patients and patients who may have failed, 5 or even more treatments. So clearly severely depressed, and on the spectrum of, the yeah, definitely the most severely depressed patients.
And then as part of the trial, you gave them either placebo or nitrous oxide, the laughing gas, one of 2 doses of that. How long for?
Well, we gave each inhalation, each session was for 1 hour. It was randomized. It was either placebo or 25% or 50. And so the patient had 1 inhalation session per week for 4 weeks. And then we did follow them for a total of 4 treatment sessions. And then we followed them basically for another month just to see the natural progression of the depressive symptoms. Because, that's the question. It's like you turn it off or you stop the treatment. Does it quickly come back, or do patients stay in remission, or do they quickly bounce back to being very depressed?
And what did you find?
Well, we found that by week 3 or 4, a large proportion of patients had a very strong treatment response. Like mentioned earlier in that session, patients who get placebo in depression studies also often have a placebo effect. So that is always something one would observe. But I think the signal was that nitrous was about, at least 2-fold more effective in those heart outcomes compared to placebo. So that's, even if you stop the treatment, a lot of patients had the benefits for several weeks more.
It's absolutely fascinating, isn't it, why these drugs with short actions, like nitrous oxide and ketamine, have such enduring effects on depression. And so I wondered if we could sort of go back to the original hypothesis, and if you could sort of summarize for our listeners what you think the neurobiology of depression is and why these agents might work. And Peter is smiling broadly because presumably this is not known.
So I think if I had the complete answer, then I probably in a year from now, I would get a call from Stockholm. No, but so in terms of the motivation, so let me start there. I did work like more than 25 years ago in mechanistic neuropharmacology research, trying to understand how nitrous oxide, xenon, how they work in the brain. I had a little bit of an insight, and I heard about the success of ketamine treating depression. And this made me wonder, it's like, if ketamine is an NMDA receptor antagonist and nitrous is an NMDA receptor antagonist, would then nitrous not also be an antidepressant? And that was the motivation for really, like, it was curiosity driven kind of the first trial. So that was about 10, 15 years ago where we published this, 10 years ago. And I think in parallel, there has been a lot of work now trying to understand on a systems level how ketamine and to some degree nitrous work. So, and it shows that the studies that have been done used functional connectivity, so fMRI, and shown that both ketamine and nitrous may basically normalize the connectivity in the brain between the brain regions that are relevant for the pathophysiology of depression. Now, there was a recent super exciting paper done out of the University of Pennsylvania by Joseph Kishon, who might be among the most talented young physician scientists in our specialty. He identified the exact brain region where nitrous may work in a mouse model of depression, which of course, question is how relevant is it for human depression, and identified a novel molecular target. So this was published in Nature Communications earlier this year, and identified both the relevance of what's called glutamatergic signaling, so NMDA receptor antagonism, but a novel ion channel called SK2 that has until then never been implicated. So it seems like there may be 2 elements to understanding sort of the neurobiology. One is what mediates the immediate onset, right? Why does it's like flipping a switch, right? And what is the mechanism behind this? And the second is, why is it persistent? Because nitrous, we know, leaves the body in minutes and at most hours, right? So why would this stay, the antidepressant effect, for weeks? So something in the brain must change. And it seems like it reminds me more of, like, we think about cardiac, like an arrhythmia, you kind of like, defibrillate or cardiovert, right? And then you have a persistent effect. So I think that analogy is like you need something that flips the switch and then maintains it. But I think we're very early in trying to understand kind of like what's behind.
As you were speaking, I was thinking about the range of depressive disorders that there are in the community. And I think we're talking about that sort of black dog, super bad depression, not the sort of blues that we all get from time to time related to what's happening at work and at home and that kind of thing. Is that correct?
That is correct. And I think it's also fair to say that in our trial, but generally speaking, psychiatrists would most often see patients who meet the formal criteria for depression, right? So there's DSM-5 criteria that you need to meet 5 out of 9 of those criteria, like depressed mood, guilt, suicidal ideation, 5 out of those 9 for a minimum of 2 weeks. So there's a difference between kind of feeling depressed, which we all are, right, to some degree, and truly having clinical depression, where patients do not have the ability to sort of heal themselves or to get out of this, right? And these patients, they need expert help. And among the depressed patients, there is really about 1 in 3, 1 in 4 who are not only so severely depressed, but who are considered what's called treatment resistant. So we have in our trial had patients who had failed 10 and more different drug treatments for depression. So these patients, we actually often don't even see anymore because they have no energy. They're at home and basically have no energy to participate in any kind of activities. It's very sad.
And I mean, you must be delighted with the result because on the face of it, giving extremely severely depressed patients for relatively short sessions of a relatively short acting agent that's relatively inexpensive.
It's inexpensive. And the drug is, as sort of the ANSCA team has shown in Enigma 1 and 2, and, is safe. Yes, there are side effects in a way of nausea and vomiting in some degrees, but it's largely safe. For me, I asked if this was kind of like encouraging. It might be the most meaningful research I've ever done in my life.
And how long lasting? I mean, you said you went out to 12 weeks?
No. A total sort of basically 1 month of 4 treatments, 4 weekly treatments, and then a second month of just observation.
Yes, sorry. So with the follow-up there, how long did the effect last in the follow-up?
We had patients who, even after a month, were at a big improvement in their depressive symptoms. And in other studies, we have seen patients actually being in remission, staying in remission for a long time. I mean, until we actually stop following them up.
From that initial single intervention, not repeated interventions, no need to come back and trial again. And it was really interesting, the data you presented in the session earlier. Is it one of the graphs you put up with the mean median? I can't remember which one you presented, but the average effects in placebo and the nitrous. But there were other lines above, below, everywhere. This wasn't a universal effect, was it?
Correct.
Lots of individual heterogeneity.
So, on average, you can see, but it was actually very interesting to see that some patients have a very strong treatment response, right? Where they truly, within a short amount of time, are really no longer depressed. And some patients do not respond, the biology of which is also really puzzling. So some patients simply do not respond, also don't respond to ketamine. And that is, I think, an interesting phenomenon that some patients, so that's why the average is better, comparing nitrous to placebo, but the variation is quite huge.
What's the next step then? Is it to look at that heterogeneity more, or is it to take it to the next stage of the trials?
So I think the logical next step to really get definitive evidence in a large multicenter clinical trial, to really study hundreds of patients and get definitive signal for efficacy and safety. I think that's really important. Now, on a more scientific angle, trying to better understand why some patients respond and why some patients don't makes it also very important, right? But this could be really going in a totally unexpected direction. So
essentially a large phase 3 trial.
Yes.
The multicenter. And
Yes.
Are you going to do it internationally or just in the United States?
Oh, internationally?
Yeah.
No, this I think would be not only, with that successful, I would say, phase 2 with Monash, right? No, I also, as the collaborative clinical trials that, that actually, ANSCA has really spearheaded, there's just, I would say, a joy in working together and doing something like this together that does not overburden a single kind of center, but also learning, right? I think would be fantastic. I would love to do this international. Yes.
It's always thrilling to hear people sound so proud about their research. To say that it's the thing you're most proud of, we're happy to be here to give you the opportunity to talk about it, aren't we, Andy?
Absolutely. And I have to say personally, I can't wait to hopefully be having a very similar conversation with you again in a few years' time after that phase 3, which sounds like it's going to be really exciting work.
You didn't invent nitrous oxide because then you would have something great to patent.
That would be Las Vegas. But maybe it's actually even cooler to have something where the chances of a really commercial success are slim, but maybe it fills a niche for certain patients that other drugs just cannot, right? And wouldn't that be cool to get something to really help patients without that kind of like, oh, you have to recoup millions of dollars? It's like to really help patients.
Well, thank you very much for joining us, Peter, and really good luck with the phase 3. Hopefully it goes ahead. Thank you all for listening to us here at home. As always, you can find this podcast on our website. That's topmedtalk.com. You can hear us on your social media platform of choice. If you do go to social media, please do hit like, hit subscribe. It really makes a difference to us at this end. We're on all your favorite podcasters as well. Lastly, as always, we need to thank our sponsors. That's BD, formerly Edward Life Sciences, BD Advanced Patient Monitoring, and GE Healthcare, without whom we couldn't keep Top Med Talk open access and free around the world. And particularly here at this meeting, we need to, of course, thank the American Society of Anesthesiologists, who've put on a fantastic show and given us some fantastic guests. Thank you again, Peter.
Top Med Talk. Thanks for downloading Top Med Talk. Don't forget to subscribe, check us out on YouTube, and of course on social media. We're on Instagram, Facebook, and X. Also, it's important to remember that Top Med Talk is the broadcasting arm of EPPOM, evidence-based perioperative medicine. We'd love you to find out more about that, and the way to do that is eppom.org. Check out our website and find out about some of the incredible conferences we're going to be arranging across the year. eppom.org.